Friends, now this is our nth lecture. Lecture n. Tenth lecture. Now we are going to discuss the Kohlrausch law of independent migration of ion. Kohlrausch. Kohlrausch law. Kohlrausch law of independent migration of ion. Friends, now see, the last lecture, ninth lecture, we have studied that the equivalent conductance versus concentration graph means this graph. Under root C versus lambda. This nature of this graph is different for strong electrolyte and weak electrolyte. For strong electrolyte, this is the nature, and if you extrapolate it, lambda strong electrolyte, and this is the nature for weak electrolyte. Now, this is the nature of graph of strong electrolyte and weak electrolyte. Strong electrolyte like HCl, KCl, weak electrolyte like acetic acid. So, what do we understand from this graph? As the lambda versus under root C is plotted, this weak electrolyte, strong electrolyte, the line is linear. And as the concentration goes on increasing, this equivalent conductance goes on decreasing. As the concentration decreases on this side up to 0, concentration goes on decreases, this equivalent conductance goes on decreasing, and extrapolation of this line, you will get the equivalent conductance at 0 concentration. Here there is 0. Practically, no, it is concentration is not 0, but the equivalent conductance is increases by dilution or decreasing concentration, and it reaches to the limiting value. Means further dilution there is no increase in equivalent conductance. Further dilution, this is a decreasing concentration, means dilution. So as the dilution increases, concentration decreases, equivalent conductance increases, and it reaches to the limiting value. For strong electrolyte, we can plot the lambda 0 value by extrapolating the graph. But for weak electrolyte, as the concentration decreases, this equivalent conductance increases, and it increases sharply or rapidly. It does not, we cannot extrapolate the line to find out the lambda 0. So, for weak electrolyte, to find out the lambda 0 is not possible. And therefore, the scientist Kohlrausch introduced the law that the Kohlrausch law of independent migration of ion means when the equivalent conductance at 0 concentration is nothing but the solution is so diluted that means in this way so diluted up to the 0 means equivalent conductance increases and it reaches to the limiting value. Further dilution, there is no increase in equivalent conductance. Is called as equivalent conductance at infinite dilution. What is that? Equivalent conductance at infinite dilution. There is a question for 1 mark. What is mean by equivalent conductance at zero concentration? Or what is mean by equivalent conductance at infinite dilution? Infinite dilution means the solution is so diluted that equivalent conductance limit is reaches to the limiting value. Further dilution, there is no change in equivalent conductance. It's called as solution is at infinite dilution and equivalent conductance is at infinite dilution or zero concentration. But for strong electrolyte we can find out the lambda 0. For weak electrolyte we cannot find out the lambda 0. And therefore this Kohlrausch says that at zero concentration or infinite dilution, each ion migrate independently. Each ion migrate independently from its co-ion. And what is the statement for Kohlrausch law of independent migration? The solution is so diluted that further there is no change in equivalent conductance. It's called as equivalent conductance at zero dilution. Equivalent conductance or zero concentration or infinite dilution. Means each ion migrate independent. Kohlrausch law states that at infinite dilution, each ion migrate independently from its coion and take its own share in the conductance measurement. It's called as a Kohlrausch law of independent migration of ion. For example, if lambda 0 for KCl is equal to L0K plus L0Cl minus, means this KCl is so diluted that the cation anion move independently from its coion and take a part in the conductance measurement. Similarly, lambda 0 for NaCl is equal to L0 Na plus L0 Cl minus. L0 plus and L0 minus, this L0 plus and L0 minus is nothing but the equivalent ionic conductances. Equivalent ionic conductance. L0 plus and L0 minus is equivalent ionic conductance. Now, if you know the equivalent conductance at zero concentration for strong electrolyte, you can find out the equivalent conductance for weak electrolyte. For example, now see, the equivalent conductance at zero concentration for CH3COOH, equivalent conductance for zero concentration for HCl, equivalent conductance for zero concentration for sodium acetate, equivalent conductance for zero concentration for NaCl. So, when this equivalent conductance at infinite dilution, this each ion migrate independently, you can write like this: L0 CH3COO minus plus L0 H plus lambda 0 L0 H plus L0 Cl minus lambda 0 for sodium acetate L0 CH3COO minus plus L0 H plus lambda 0 for NaCl L0 Na plus L0 Cl minus. Means each ion migrate independently and take its own share in the without respect to its coion, independently migrate and show the ionic conductances. The conductance of each ion show the ionic conductances. Now, once you know the equivalent conductance of acetic acid, HCl, sodium acetate and NaCl, you can find out the equivalent conductance at zero concentration for the weak electrolyte. How it can be found out? Now see. How you can find out the equivalent conductance for weak electrolyte if you know the equivalent conductance of strong electrolyte HCl, sodium acetate strong electrolyte and NaCl. So simply you can write lambda 0 for HCl plus lambda 0 for sodium acetate CH3COONA minus lambda 0 for NaCl. So if you add these two and minus NaCl, then this Cl minus, if you write like this, Cl minus get cancelled, Na get cancelled, you will remain the CH3COOH only. How you will find out this? HCl. So what is HCl? L0H plus L0 Cl minus. What is sodium acetate? L0 plus this plus L0 CH3COO minus plus L0 Na plus. Okay? This is the addition of two strong electrons. Ionic conductances of HCl, ionic conductances of sodium acetate. Now minus ionic conductances of NaCl. So NaCl L0 Na plus minus, it is minus. So it will be minus Cl minus. L0 Cl minus. L0 Cl minus. If we add these two and subtract the NaCl, you will get this LCl minus, L0 Cl minus get cancelled. L0 Na plus minus LCl minus cancelled. Only remaining that ionic conductance L0 H plus ionic conductance of CH3COO minus, and is nothing but the lambda 0 CH3COOH. This is nothing but the equivalent conductance at infinite dilution for weak electrolyte acetic acid. If you know the equivalent conductance at infinite dilution for strong electrolyte HCl and sodium acetate and NaCl, you can find out the lambda 0 for weak electrolyte acetic acid, and therefore this Kohlrausch law is given. Thank you very much.